Hello friends, welcome to the day 17 session. So in this talk we are going to see about some of our libraries and some of our real-time applications but the basic one. So we are going to see the basic versions of supervised and unsupervised respective learning algorithms. So before starting the today's session, let me just quickly run for yesterday's part. So we have been just seen how to make a concatenation, how to just have different datas. So like how to perform this concatenation in pandas. So the various options have been just provided in pandas for concatenation as compared to a numpy, and we have been just seen other functions as well, and we have been just seen how to take a real-time data set of a Melbourne city, and we have been dropped the NAN values, not a number of values, in an axis of that is a rows. So the whole row will be just deleted whenever a single NAN has been just provided. So we are going to print after NAN values, and we are taking a X and Y values. So X is a features, Y is a price. So this is an regression problem. Okay, then we have been just seen what are the features, what is the price, and what is a pandas is going to understand by seeing the by seeing the data set. It has been provided how many non-zero number, 25% of it, standard deviation of it. If I am considering a bathroom, what is the land size? So what is a non-number land size, that is how many square areas? In that non-number values, what is the mean of it? What is the standard deviation of that land size? So if you are having some 18,000 land sizes, in that what is a non-zero value? How many non-zero value? What is the mean value of it? What is the standard deviation? 25% of that, 70%, sorry, 75%, 50%. So like this it is going to describe. And what is this head is going to do is the column names. So that is a first row element names will be provided or printed by using this head. So these are the things we have been just seen in the yesterday's session. So today we are going to just have a MATPLOTLIB SCIKIT-LEARN. This is a package which is going to have almost all the classifiers with supervised and unsupervised algorithms have been just written in this packages. So we have been just seeing today, and we have been just solving some of the basic versions like how to differentiate or how to make a decision by a basic problem. It is not a real-time problem, but basic versions we are going to just see with. Okay, we can just go to the next one. So today I am going to speak about matplot library, as I told you earlier. So which is used to get an output. Okay, and just see what is the usage of a matplot library. So scikit packages, some of our sample codes on supervised. In supervised we are going to see linear regression and Neves bias. So some of the sample codes on unsupervised using Gaussian clustering or GMM. See here what we are just doing is just seeing how to code it. So in the next sessions, that is in the next video, we are going to see the what is a mathematical part of all this supervised and unsupervised things. After getting a mathematical part, we are going for applying those mathematical part on a real-time scenario. So this is like just a coding part, how to just get familiarized with the kit, that is a scikit package. After getting familiarized, we will be discussing about a mathematical issue, that is how mathematics is going to play a important role in machine learning and what exactly the equations are present for regression, Neves bias and all. So later, after looking all those things, we are going to apply on real-time applications. So next one is MATPLOTLib. So this is a library which have been just provided. So MATPLOT, P-L-O-T, yes, sorry, a typo mistake here. MATPLOT, sorry for it. So after this, okay. So matplot library, so it has been used to display output. So it can be a images, or it can be a graphs, or it can be a pie graphs, or it can be a line spaces. So matplot library which is used to display and output images. So it can be images, it can be graphs, or it can be any sorts of a pie graphs. So like these are the things you can be just displayed. So these are the basics of the things going to be just changed with. So whenever the basics, so we cannot just make all the things like what are all the packages which are coming under a Python, but for machine learning we need this package to just work for seeing the output. So that's why we have been just included here. So this is like used to display the output images, graphs, or it can be an discrete graphs, pie graphs and all. So we can just see some of our examples here. So how to install and usage of a matplotlib. So the installation is same. We are going for pip install matplotlib. As usual, this is a package name and rest becomes same. Pip install matplotlib. So import matplot.pyplot as pld. So this is a how to make a usage of a matplot library. So import matplotlib.pyplot as plt. So this is again a nickname. So instead of writing all this respective words, you can just write as plot in your program. So if you are not familiarized with these things, like you can use both the things like matplotlib.pyplot. So instead of typing all these bigger words, you can just use only a 3 letters. So this is like a replicator of a respective package. So you can just use this package name or a variable to access the pyplot which have been present in matplotlib. So that was all about matplotlib. So let me just go for just showing how this matplotlib is going to work with. Okay, let me take a new file, new scratch file, Python 17, rename, day 17. So we are going to reflect it. So first let me install this. To do this we need an internet connection. So go to terminal here. So pip install matplotlib. So it will collect the matplotlib from a server. So that is a Python server, and it is going to just install. The installation time is going to vary based on the internet speeds. Now let me check the speed here. It's working. Okay, matplotlib, it has been just downloading from a server. Okay, it is of around 9 MB. So once it has been just downloaded, you need to have a indexing as well. That is, there will be some indexing is going to happen after installing every packages. Okay, it is just downloaded and it is going to install now. So once it has been installed, we need to wait for an indexing as well. If indexing is not going to happen properly, then it is just not going to invoke the programs. Okay, you can just make it a manual. Go to file and validate catches. So this is called indexing. I was being just explaining about after installing any of the packages. So it is going to index. So let me just invalidate it and restart. Let me see, will it invoke or not. If it is not invoke, we will just make it invalidate and restart. So import matplotlib dot pyplot as plt. So you are just invoking a matplotlib. Inside the matplotlib, you are having pyplot, and you are invoking it as a plt. And you need a numpy as well for creating a matrix for displaying a dummy values. So we are having a one of a function in numpy called line space. So equally the values are going to be distributed to 1000 with an increment of 10. So how to use this matplotlib is, so plot plt dot. So instead of writing the full name here, instead of writing this, we are using plt, and this plt have been used here. If you are using plt1, you need to use plt1 everywhere in your program. So like this. So plt dot plot. So we are using a plot function inside it. What you are plotting, x comma np dot sine of x. So we are just plotting some sine waveform here, and we are just providing how to display it. So this is like this symbol, in this dash dash dash, the sine wave will be displayed. So again you are using plt dot plot. So you are taking the same x value, but instead of instead of sine, we are using cos for differentiating purpose. How exactly the matplotlib is going to work with. So for displaying the cos, you are using double hyphen. So you can just see that in an output. So now you are using matplot show. So this one is like how to just plot it. So for sine, we have given single dash. So it is being just provided. For cos, we have given double dash. So this is a difference for having sine wave, sorry, having two different plots. So like this. So this is a version. So like so you can just give a title here as well, sine and cos. So the simple function is you need to call a title, title. So you can label x-axis and y-axis. So in x-axis you can give it as a time. In y label you can give it as a amplitude. So like this you can just have a different operations here. So you can just see in the output, in the x-axis we are having time, in a y-axis we are having amplitude, and the title is sine and cos waveform. You can just change it. So this is like generating a waveform. So now you can just see how to save it, how to save to the current directory. So current directory means working directory. So next we can just see how to save your file or save the output into the respective folder. So first thing is you can having a figure. So plt.figure. So you are just calling a function to save the output to the files. So figure I am using. What you are using, use a function called save fig, and you can just give figure1.png. You can just give the extension of it. So you can just see there are no figures here, so you can run it. So in scratches you can see that the figure1.png have been saved. So this is a method for saving the output into the working directory. So this was how to use a matplot library as PLT. So you're plotting it. So for providing a title you can use plt.title. For providing a name for x-axis you can name it as x label. For y-axis you can name it as y label, and you can name any of a user defined value inside the quotes. You can use single quotes or double quotes, single or double. So now we have been just taken a simple sine wave and a cos wave, which have been differentiated by the lines for representation purpose. So you have been just plotted and you are just showing it, and this is a procedure for creating or saving your file or figure to the respective folders. So this was all about how to create a simple output window using a MATPLOTLIB library. So next one is we are just seeing what is subplot and how to use the subplot. So consider this is your output window. So this is your full screen output window. If you are using plot for full screen, only one image will be displayed. So if you are going to compare the various images, you need to divide a window into subplots. So this is a subplot 1, 2, 3, 4. How to create this is, it is having 2 row and 2 columns. So 2 into 2, it is going to store 4 respective figures, and these are all the index. By using this index, we can access this window and you can just plot the user defined figures or respective values in it. Okay, we are going to access the accesses. So it is going to access based on the index. So index will be starting from 0, 1, 2, 3. So this is a 4 indexes. We can just display the 4 values like this. If you need more than 4, you can just have a access, you can define the access and you can just print the values over there. Let me show you. Figure comma access is equal to plt dot subplots 4. So here 4 actually says the how many plots can be printed, can be displayed. So if you need 4 figures, you can just give it as a 4 here. So as of now, I am having only 2 figures. I am just changing the axis to 2. So only I am having sine and cos. So axis of 0. So this is the index 0. It starts from 0. 0, 1. You are having only 2. So what you are plotting, axis dot 0 dot plot. What you are plotting here, x comma np dot sine of x. So you are just plotting this one. So next, axis 1, you are accessing it, plot of x comma np of cos of x. So if you need the other value like tan, you can go for it. Plot x comma np dot tan of x. So like this, you can increase the axis by saying how many subplots you have been just needed. So you can just go for this figure. Okay, it will execute. So it will save the figure again, this figure which have been just provided. So later it is going to plot the 3 different plots. So in x-axis, so in first plot sine, second plot cos, and the third one we are going to have tan. So the screen will be divided into 3 subplots. So this was the first one, sine and cos. X-axis is labeled as time and y-axis is labeled as amplitude. So after closing this one only, the next plot is going to happen. System is getting slow. So you are having 3 different plots here. Okay, X is not defined. So you can just see the plots like this: sine, cos, and a tan. So your full window have been divided into three subdivisions. First will be sine, second will be cos, and the third one will be tan. So like this, you can divide your whole window into respective subplots. So in order to do this, this is a procedure for this. So next, we are just going for SCIKIT package. So this is another packages which are being just provided in Python to learn the machine learning packages. So what is this scikit-learn is going to do is, so create the models. So create the models from using the data provided by the user. So as I told you earlier, in machine learning, model is like a piece of software, training a piece of a software to perform the prediction. So technically, instead of saying the software it as a software, do follow by telling it as a model. So what the scikit package is used is to create a model. So the model is created by using the data provided by the user. So this is called as an scikit packages. So what is the task of a human being here? Human being should convert the data for a computer understanding format. So data what we are seeing, data, we can understand it as a letters, and the word is going to give the name or meaning as data. So it is going to give some computer data or something like raw data or something like this that human beings will understand. But what is the job of a human is to convert this data into machine understanding format. Machine understands only numbers. So convert anything to the numbers is a task of a human being. So data will be like as a table. So like a table means the data set will be provided in the form of CSV files. And as you've seen in the yesterday's session, the data set, so that will be in the form of tables like this. So you'll be having column 1 name, you'll be having column 2 name, column 3, and you'll be having labels. So here we'll be having a number of values like row 1 value, row 2. In row 1 you will be having a first object or a first data. So like this you will be getting, in the yesterday session we have been seeing 18,037 some odd value of our house values. So that was an unsupervised thing what we have been just seen. So here we can just see the example data. So first we need to install this pip install scikit-learn. Can close this. Okay. It takes some time. Okay. Whenever I say it takes some time, it will start collecting the scikit-learn. Oh, 31 MB. Okay, 5 seconds. Not bad. Speed is good. The speed doesn't depend only on your internet speeds. It also depends on whether the server is providing a good speed or not. Okay, it has been collected. Let it get installed. After installed, it need to be indexed. Again, we need to wait for indexing. So we can just see here, indexing is going to happen. So this is what the bar is going to say, that indexing is updating. So till the updating of this index, we cannot use those packages into our programs. So it has been installed, and it is waiting for an indexing. So before indexing, we cannot start any of the things. I guess the indexing have been completed. So we can just see how to import Seaborn as CNS. So here we are having some of our data sets. So we are using a iris data set in it. CNS dot load data set. It is a sub function which have been used in CNS, that is Seaborn. So you are accessing only iris over here. So iris dot head, we are just displaying what is the head values over there. So that will be in the form of tables. So we can just see what is a respective output. Okay, we can just invalidate it and restart. Let it get restarted. If a problem persists again, we can install the Seaborn manually.
Okay, cool. 17399538. So you're looking for a unit manager. How is it a
So let it get indexed. So if it is not indexed, we cannot use programs. It just generate errors. So in the meantime, we can just install the Seaborn. It has been already installed. Let me just see. So click install Seaborn. Okay, after installing, again it may index. Okay, it is a background task. What is this analyzing? Okay. Okay, we can execute this and see whether it is generating the same error or not. So if an error persists, you can also install a Seaborn manually. Okay, we can just go for our next file. It is not just invoking here. Okay, we can just see the iris head. So the features here as sepal length, sepal width, petal length, petal width, species. So the table head, what is the column names? In that we are having a features here. For this feature, the species is Setosa. So like this, they will be having many species. So here you can just see the print. Okay, print head in the same manner. If you are having any describe here, describe was in pandas, but let me see whether it has been available the same in Seaborn or not. Okay, it has been available. So these many count values, 150 each species have been just there. For each species, so for total species we are having 150 in that mean value, standard deviation minimum 25%, maximum feature of sepal length is 7.9. That is a maximum feature value. So this is like the data will be in the form of tables. So that is what I was being just telling about. You will be having features and finally the label. So label here is the species, which species does it belongs to. So that is what whenever you are taking any of a data set, that will be in the form of data. One part of a data in supervised learning will be of having features. Another part, the vector format, that last column will be in the form of labels. So that is what this respective thing is going to just explain you. Data set will be in the form of tables. So how should be the data set? So how the data set should be like, you will be having some n samples. So n represents how many samples you have been taken. As per the yesterday's session, it was having 1800. So starting from 0, 1, 2, 3, 4 till it reaches 1800. So this is n samples. So after having n samples, you will be having features for all the samples. So for that pandas, for that iris, we have been just having a features called sepal length, sepal width, and next one, what we have been just seeing, sepal length, petal width. So sepal length and petal width. So based on that, species are going to be identified. So now you are understanding that machine understands only the numbers. So human is converting his respective application to the numbers. So this is sepal width and sepal length. So the next one is petal width and petal length. So for each features you have been provided with the labels. So the labels here is in the form of category. It can be status quo, it can be any other forms of a species that will be in the form of one column. So this is features. So this is labels. So we are going to call this labels as a target array. So in the next slide we are having target array. So this one. So this target array means labels that is in the form of only one column. So these are all the features and these are all the labels. So that was all about target arrays. So we can just see how this data set have been just provided in a real-time scenario. This is also a real-time application. We are having a distinguish of a different species of a respective iris. So it is kind of a flowers or something like this. So how data set should be present is, first part will be features. So for every samples you are having this fixed features. So if you are having images will be converted into 4 feature: sepal length, sepal width, petal length. So petal means, so you can just imagine like a leaf, and a flower. So you'll be having sepal and petals. So this length and width is going to be calculated. The same manner for sepal also. So length and a width is going to be calculated, and some numbers will be there here. So if these numbers have been present, nearer numbers have been present in your real-time images, the machine will say that it is a species of status quo. So let us have some of our sample codes here. So sample codes will be provided here. Deeper analysis of building classifier from scratch is from a next session, and it is quite mathematical in nature, and this is going to happen in next session. So I would just suggest you to brush up your linear algebra. So your linear algebra need to be brushed up. Your probability, randomness of occurring of events, that need to be brushed up, and some of the features like A probable with B or A union with B. So you can just brush up it. I will be just covering with I will be also covering, but you can just have a brush up of all those things, probabilities, linear algebras and all. So let us see some of our sample codes here. So let us go to PyCharm. So next the same thing we have been just used, just the second has been stopped. So we are setting this to work as an default working directory, xns.set. For this directory it will be just get settled. So now we have been just loaded a iris data set. Next we are going to see how it is going to work on this iris data set. So x.iris. So as I told you earlier, you need to form a table, x and y. X will be having features, y will be having labels. So iris.draw. So if you are having any of what is this, non-zero value in a species, so species will be in column. So that's why I'm axis I have been mentioning it as a 1. So in any of a column, NaN is present, delete the whole respective values. So x-axis will be equal to iris.drop. In the same manner, you are shaping this value. You are shaping this value. So you can just see, you can just print it. So print x iris. Or you can print this one itself. So run it. Sorry. So shape means you are having 150 species and you are having a 4 different species of it. So 150 in number, 4 different species. So wherever you are having any of a non-zero value, you are going to drop it. That respective digit will be dropped. That's all. So this is how to have a prepare your data set for target arrays. So target array means if you are having any of a non-zero one value, it will be just deleted. So this is like how to take a data set which have been already available in CBOR. So let me just so we are having some of our sample examples of a supervised learning, or how to predict a new value for this unsupervised learning. In supervised, we are having linear regression, and we are having a what is this another value what we have been just mentioned, that is Nevis bias. In Nevis bias, we are having some of our types: Gaussian Nevis, ridge Nevis. In that, for an sample thing, we have been just showing you how to work with the sample data. So the values are like these are all the created data sets. For the sample codes, we are using created data sets, and we are using this iris data set for performing supervised machine learning for Nevis bias. For linear regression, we have been creating some dummy data set. Okay, so going to the what we need for this linear regression, let me take a newer one. So import matplotlib dot pyplot as plt and import numpy as np. So I am taking a random values, a range of values, by using a command called random and the random state of 42. So some random values will be just provided, the range of values. So we are having x is equal to 10 into range. So range have been created, and I am using a random values for this of 15 number. So y-axis, so 2 into x minus 1 plus range of random negative numbers, so it is RNG, and this should also have the same numbers. X and y should have the same values, x-axis, y-axis. So it should act as a table now. So this is the equation for linear regression. Y is equal to mx plus c. So that one we can just see what is this regression, linear regression, what is the theoretical part of it in the next session. For this class, what you need to just understand is, in order to differentiate between the cells, we are going to have some straight line. So this straight line, so for differentiation purpose, you can understand that between two countries there will be one boundary called straight line to make a difference between one country and another country. So in the same fashion, to differentiate between two classes, we are having straight line. Linear means straight line. Y is equal to mx plus c. So we are just plotting the scatter of x comma y. So we are just using it. So after getting a data set, so this is like preparing a dummy data set. So after doing this, we are going to choose the model. So we are going to choose the model as linear regression, and this linear regression have been present in SCIKIT-LEARN linear model, and you are going to import linear regression. SCIKIT-LEARN, we are going to just import a linear regression. So here we are just having one model. So we have been imported a linear regression here. We are just calling the same linear regression, and we are just telling that fit intercept is equal to true. So we are having a theory part for this. In the next sessions, we are going to see what is linear regression and what is Navier bias and all. So in linear regression, we are going to have a intercept concept. In that intercept, we are going to make it as a true here. We are taking a data x np dot new axis. So new axis means, so this is a table. For a new axis, it is going to create another axis for labels, and you are going to have a shape of it. So you are going to have a shape. So now you are going to perform a training here. So model has been there, you are going to perform a training. So model dot fit, you are going to have x comma y. So once the system is what is this, it has been just trained, so you can just go for a prediction. So prediction of new values. So x fit is equal to, so we are creating a new values here, np dot line space -1, 11. So y fit is equal to y fit will be equal to model dot predict of capital X fit. total xfit will be equal to xfit np dot new axis. So you can print yfit. Okay, instead of printing we can plot it. So plot dot scatter x comma y plot plt dot plot xfit comma yfit. So here you are lagging the theoretical concept of linear regression. You may find what is this fit intercept. So whenever you are going to see what is the theory of a linear regression, you will be get clear what is this fit intercept actually means that. So here we have been just prepared a data set. For training a data, we are going to use a function called fit. So after trained data is ready, the model is ready, it can take a new data. For a new data, you can predict the what is the newer values. So this is a scenarios. So let it get execute. Why it is taking too much time? Okay, the figures are not visible. Why? Because it's like after plotting this, we need to say that show function, or else before seeing only it will just display and it disappears. So for everything you can just have a plot dot show. So after closing this, why it is taking too much time? Yeah. So this is a scattered curve, or wherever you have been generated this one. Plot scatter or between x comma y. X is some random values 50 and y is 2x, that is slope mx plus c. So this is a random lines which have been just generated. This is a data we need to just separate with. So for this data we are applying a linear regression, so that is a straight line to make a difference between two lines or points. So this is a data set. So for a data set we are using predict. So for a new data, how it is going to predict. So this is thing. So this is a scattered. So this is line of fit of plot of x comma y. Okay, so that was all about how to make a differentiation between straight lines. So this is our data. In this data we are using a straight line to make a difference. So this is like how the data is going to be fitted, and this is a linear regression curve which have been generated after having your predict. So plot x fit comma y fit, and we are showing this. So if you are getting confused, so before plotting you can just plot with the title. So here also the data set you can just make it as data set. So this is dummy data set generated. Okay, you can run this. So this is a dummy data set generated by using a random state values. So this is a prediction. So it has been just make a prediction of straight line. So this is called linear regression. So it has been trained with the models of x comma y, and it has been made a generation. So saying that you are going to make a linear separation between two classes. So this is a dummier one. So this is a basic one. So you can extend this to some of our applications. So I guess this will become too much clumsy to understand without knowing a theory. So let me take this SCIKIT sessions soon after, or Seaborn with the SCIKIT learning packages soon after completing the theory of what is linear regression, theory of what is Navis bias, what is SVM. So if you are finishing all the classifiers, so you can just implement those classifiers on a basic algorithms or a basic codes like this first, and later you can extend it to phase detection, you can extend it to prediction of a bicycle traffic, cycling of a so usually in outer states or in other countries inside the universities or in IISc, you will be seeing that the cycles will be provided for visiting the universities. So in IISc, so in the same manner in other countries like US and all, for cities also they will be using the cycles. So in order to find what is the density of cycles during Sunday, Monday, how it is going to change with the temperature, rainfall and all, we can just see that by seeing the application of a linear regression. So in the next session we are going to see about what is the theory of what is the equations of a linear regression. So after combining the theory and the coding part, you will just get clear. So the next sessions like the sample coding of non-unsupervised method Navis bias, I will complete that after finishing the theory. See, like coding is not an issue, like you can just have a syntaxes, you can just import some coding values like SVM, SVC of a Navis bias, and you can just implement it. So the thing is, you need to understand the theory. After understanding the theory, you can code it, so you can correlate it. So that's it. The sample codes I will just continue soon after completing the theory parts of linear regression, Navis bias, SVM. So that's it for this video, guys. Let's meet you all in the next video. Thank you for watching.